Mathematics, the word operation does not mean slicing and dicing your body open and maybe taking out your spleen or your liver. Operation in the math sense means adding, subtracting, multiplying, and dividing. I actually went over that the other day. So we're going to be able to add, subtract, multiply, and divide polynomials. By the time I'm done with you, you should know how to do all four. Veteran students already know how to do that. So the cool thing is, veteran students, if you have the upper hand right now, what I want to do is I want to summarize adding, subtracting, and multiplying first. Go ahead and make a table on your notes that looks like this. Here's the operation, and here's what to do. Take about 3-4 minutes. Copy down this nice table. Make it nice and big on your notes, because this is something you're going to refer to often, especially with the gallery walk today, when you guys walk around class doing some problems. How do you add polynomials? Well, you combine like terms. That's how. That's what to do. Subtract polynomials? Well, distribute the -1 to the second polynomial and then combine like terms. That's how. And how do you multiply polynomials? Multiply every term in the first polynomial by every term in the second. And you're done, hon. Go ahead and take some time to copy that down. How do you add, subtract, multiply? Again, veteran students, you should be laughing right now. We just finished the last quarter one with doing this, right? So this is easy. I'm going to start off with a geometric example. That's not going. Let me go enter a shape here. Where's the shapes here? Here we are. Let me draw a rectangle for me. Example 1. Find perimeter and area. Let's draw a rectangle there for me. Let me fill this puppy in here. I'm going to fill it in with Dodger blue. I've got a Dodger blue rectangle. Okay, draw a little rectangle, example 1. The mission is to find the perimeter and area. Veteran students, again, you should be laughing right now. Let's make the width, let's say x plus 1. Let's make the length x plus 7. How about that? First number that came to my mind. Let's find the area and perimeter. Perimeter of a rectangle. The perimeter of this room, if I want to put some new baseboard, go to Home Depot, perimeter is just the outside border of a shape. So the perimeter of this classroom would be the outside border. So the perimeter of this rectangle is the outside border, which means I'm just going to add up all the sides. It's the outside. Watch this now. Ready? X plus 1 plus x plus 7. What's this side right here? X plus 1 also, right? Because in a rectangle, the widths, the opposite sides are always congruent. They're the same. So this is going to be x plus 7. Rock and roll. So the perimeter then, ready? P, perimeter, just add up all these sides. X plus 1 plus x plus 1 plus x plus 7. You know what? I'm putting multiplication on. I should put addition. I think my coffee hasn't kicked in. Put the coffee. X plus 1 plus another x plus 1 plus an x plus 7 plus the other x plus 7. Write that down. There's your perimeter. Perimeter just add up the sides of a shape. The border, the outside perimeter. The boundary line, so to speak. So we're adding polynomials. We're adding binomials here. What do I do when I add? Look what it says. Combine like terms. Let's combine like terms. Let's do it. I got an x, another x, another x, and another x. How many x's are there? There's 4 x's. So perimeter is equal to 4x, and I got 1 plus 1 plus 7 plus 7. I'm bad with mental math. What's 1 plus 1 plus 7 plus 7? 16. We're done. Perimeter. There's your perimeter. Easy. Yeah. How about area? Veteran students, anybody remember how to find the area of a rectangle? Maybe even a non-veteran student. How do you find the area of a rectangle from junior high? Length times width. Thank you. Area is length times width. The area inside a rectangle is you take the length and you multiply it by the width. Here you go. Length is always your longer side. So length is x plus 7. Watch this. X plus 7, excuse me, x plus 7 times the width, x plus 1. We're rocking and rolling. Again, those from last quarter should be like, man, this is easy. Easy week. Enjoy it while it lasts, because you'll be challenged soon. Even better students coming soon. Here we go. All right, how do you multiply? We're multiplying polynomials now. We're not adding anymore. Let me go up. Let's go up. Let's see. How do you multiply? Oh, here we go. Last one. Multiply every term in the first polynomial by every term in the second. That's it. That's how you multiply. In other words, x times x, that's this term, I'll multiply by everything. So x times this and then x times 1. And 7 times x and 7 times 1. Every term here, multiply by every term of there. You're done. But you have to combine like terms in the end because it'll get kind of messy. Let's do it. X times x is really this. Look at x times x. Plus x times 1 is just 1x, right? Plus 7 times x is 7x. Plus 7 times 1 is 7. What is x times x though? Square. Thank you. X to the second power. Plus x. Plus 7x. Plus 7. Like terms, help. What are my like terms here I can combine? 7x and the 1x, huh? There's a 1x there. That makes 8x's. Here's our final expression, ladies and gents. So the area is x squared plus 8x plus 7. We're rocking and rolling. So in this one example, I actually covered two operations, adding and multiplying. No big deal. One more example, we're done with our notes. Here we go. Questions so far? Tell me where I'll stop. Right there? So look at 80. How did I get the 8?
Yeah.
1x plus 7x.
Oh, I see. Oh,
you with me? Just combine like terms, right? Exactly. Combine like terms.
Oh, and then you just leave the other ones the same?
Right, because there's no more like terms on. You can only combine like terms. Same terms with the same variable raise the same power. Last example. Example 2. Let me throw a trinomial at you. X squared plus 7x minus 8. Watch this now. Minus 6x squared minus 2x minus 3. Just making up as I go. Last example here. Okay, we're subtracting now. We're subtracting polynomials. What do? Let's go up to the table. Look at subtraction. Distribute the -1 to the second polynomial and then combine like terms. What the heck does that mean? Well, what that means is, look at, there's a -1 right here outside the second polynomial. Veteran students, you can do this in your sleep. Distribute the -1 here, see, into the second polynomial. That's what it says. Distribute the -1 into the second polynomial. Okay, here we go. Negative 1 times 6. What does that become? Help. Negative 6, huh? X squared. Negative 1 times negative 2. Positive 2x. Negative 1 times negative 3 is positive 3. Now we're ready to rock and roll. Let's combine like terms. That's what it says. Think of the rule, that table we start off with. Then combine like terms. Let's combine like terms now. This first polynomial, combine terms with the second polynomial. After I distribute the negative 1, let's combine like terms. In other words, terms with the same variable raised to the same power. You guys defined like terms yesterday on your notes, that note guide. Terms with the same variable raised to the same power. What's the coefficient here? Thank you. There you go. 1 minus 6. Negative 5 what? X squared. I like to cross them out when I'm done. I'm just combining like terms now. 7x plus a 2x to 9x. Negative 8 plus 3 is a negative 5. For rock and rolling, here's our final expression. We subtracting the polynomials, we're good to go. Sweetness.